Good morning, student.
Good morning, sir.
We will be a little slow in this class because we are going to talk about media optimization. There are many things you need to understand, and you should be very careful in these coming days. It will be very much useful in your future also, not only in this class. When you are doing projects or higher studies, definitely much useful. So I'll come to this point soon. Basically, when we are talking about media optimization, we are essentially talking about a situations when there is multiple options are available and you are interested with some job. So for example, if you simply say someone is making a cake, right, and you know the ingredients, of course, but maybe for everyone the ingredients remain same. But do you think everyone will have the same product output? No. Someone's quality will be good, someone quality will be maybe better than other. Someone can have worse formulation. So basically, there is always a recipe, and when you are going for a recipe, how you will normally do? We can do many approaches are there. And the first one approach is a trial and error. Let me come to the point using some examples here. Okay, I think you can see my screen. If not, I'm just presenting now. Yes. So we are going to talk about media optimization. Why you need to optimize? This is the first question. So for example, I had found out that we are having a microorganism, and I'm giving you a media composition. For example, as reference media, I found out one new microorganism, and for example, I'm using glucose and I'm using ammonium chloride, for example. I'm using peptone. I'm preparing the media using this. Okay, or only 3, or maybe many more. And for example, we are normally using, for example, in my case, I'm using some 10 gram per liter. This is 1 gram per liter. Peptone 100 milligram per liter. Like that I'm using. Now I'll have very simple questions to you, or maybe to myself even. So we are growing some culture using this media, and after, for example, after 24 hours, I am measuring how much biomass has grown, right? You can do that. And for example, you are starting with biomass of just 0.5 gram per liter. After 24 hours, I am getting some 7 gram per liter, for example. Okay. Now question comes, is there any way that we can modify it? Can I have more biomass if I change this media, not only 7, and how much more, basically? So this is the questions. This is the coming a question of optimization. Many things are there, and what could be the optimal values we can have in that situation. So basically then we will say, sir, if I increase the glucose and increase the ammonium chloride, and if you do the media, what do you think? It will increase or not? Because for microbial growth, I know, or you also know, maybe glucose is very important, ammonium chloride is very important, peptone is also very important. But if I'm saying everyone is very important, then what is not important? We need to also understand that. And how much is important? Okay, I'm telling glucose is important, ammonium chloride is important. But I'm giving any scale that, okay, glucose is very important, any numerical value of importance? Nothing is there. So basically, if I ask you that, okay, this is the reference, this is called reference value. Reference means from literature, from your experience, from your guide, some values you are getting as a starting point. Okay, so this is called starting values. Some composition I'm telling you, 10 gram per liter, 1 gram per liter, 100 milligram per liter. and I'm growing it for 24 hours. Maybe I'm growing at 30 degrees centigrade. Someone may say, no, you can use this media, but if I grow at 37 degrees centigrade, you will find very good growth. Okay. Then question comes, how will you finalize which is the best one? I want to know for the best. So to know for the best, the one simple approach is that, okay, you try. So always there is an option called trial and error. Okay, I will try many things. So for example, I'm keeping everything same. Okay, I'm keeping ammonium chloride same, peptone same, temperature same, but only I'm changing glucose. So how will you do that? For example, I'm changing glucose and I'm doing multiple sets. Try to understand. So for example, in one case, I'm using 1 gram per liter glucose. Somewhere I'm using 5 gram per liter. Somewhere I'm using 10 gram per liter. Somewhere I'm using 20 gram per liter, and maybe 30 gram per liter. So basically, if I am having a media which is made up of multiple things, but I am changing only one, because anything can change. So what I am doing, I am making a multiple batch, not only one set, right? I am doing a multiple batch. So for example, this batch. So for example, 5 or 6 batch I am creating. Okay. And each of the batch, the media is different. Here maybe other things are same. For example, I'm writing glucose, ammonium chloride, and peptone. So ammonium chloride, peptone, I'm always keeping 1 gram per liter, 100 milligram per liter. So this is always constant. For example, I'm keeping. And glucose I'm changing, as I told you, 1, 5, 10, 20, 30. That means I'm having 5 flasks of different concentration of glucose. And then what I will do, I will grow it for 24 hours, maybe at 30 degree. And then I will measure how much biomass. So maybe I am getting that, okay, in this one, in 1 gram per liter, for example, I'm getting biomass of 2 gram per liter. For example, 5 gram per liter, I am getting biomass of 4 gram per liter. 10, I'm getting, for example, 7 gram per liter. For example, I'm getting here 8 gram per liter. Here also I'm getting 8 gram per liter. So what does it mean? I can make a plot, yes or no? So try to understand that, okay, I am doing multiple batch study, and this is glucose concentration, and this is biomass. So I'm plotting this one, I'm getting this one, I'm getting this one, I'm getting this one, I'm getting flat. So maybe I'll say, okay, if I increase glucose, always I see that biomass is increasing, but after some time it is flat. It may happen. So I understand increasing glucose is always good, at least up to this point. So what I will say, okay, sir, this glucose is the best one I find. So you had a media which contains glucose, ammonium chloride, and peptone, and we finalized, okay, glucose 10 gram per liter is not good. And for example, I found 20 gram per liter is good. Am I clear, sufficient for you? So what I am doing after doing this study, I am fixing, okay, glucose is, I am fixing now 20 gram per liter. That is fixed. So I am just giving a certification, okay, glucose is this. But then another thing is there, ammonium chloride is also there, peptone is also there. Then what I will do? I may say, okay, once glucose is fixed, then I will change only peptone, or maybe ammonium chloride now I will test. So first you do one set of experiments, like here, I'm doing only changing glucose, multiple, I may do some 10 set, 20 set. Then I'm confirming glucose. Then I'm keeping this glucose fixed, and ammonium chloride I'm changing in different values, like that, like glucose as I have done, same process I'm following. And then I'm finding ammonium chloride value also, which is the best one I'm trying to find. And for example, I'm finding this is 0.5 gram per liter is the good one. Whatever I'm using is not good. So that also I am now fixing. Then third, these two are fixed. I'm not changing these two. Then I will say, okay, peptone is there, na? So I will do the same study with peptone. I will change 100 milligram per liter. I will change into another values, and I'm changing this one also, peptone also. I'm changing, and I'm finding the the best possible one I'm trying to find. Am I clear? So for example, peptone, I'm getting 300 milligram per liter is the best one. So basically, every time I'm not changing many. Why I'm not changing many? I'm only changing one. So that you understand that making glucose 20 gram per liter is the good one. So basically, try to understand how we are going to do the job. So basically, we started with 10, 100, right? We are starting with 10, 100. I'm changing only this and I'm approaching 20 gram per liter. I know how much value. Of course, other things remain same. Next time, I'm testing this one. I'm testing this one. Other things I'm keeping constant. And for example, as I told you, this one was not sufficient. I reduced to 0.5 gram per liter. This 100 remains. Next time, what I'm doing, I'm keeping these fellow things. I'm only changing this one, right? And I'm reaching 20 gram per liter, 0.5 gram per liter. And for example, this is 300. Okay. If I am doing this kind of approach, and of course, in this case, I had some 5 set of flask, right? I have 5 flask I have done. Here, for example, again, 5 flask I have done. Here also I have done 5 flask study I have done. So basically, I have done 15 flasks. And finally, I am telling this is the best media, right? If I am telling like this approach is known as one variable at a time, or simply I can say this approach is called OVAT approach, one variable at a time. Am I clear to you what is OVAT approach, how it is normally done? Can I get any response from you people, please?
Yes, sir.
You understand, right? Okay, this example, if you understand, then I'll ask you a few more questions. First of all, you try to understand that we tested only 5, 5 and 5. But have we tested all combination? Of course not. Of course not. We have not tested. You are telling that, sir, 20 gram per liter, 0.5 gram per liter, 300 milligram we tested. Have you done any testing for 300 milligram of, for example, I'm writing, this is carbon, this is nitrogen, and this is peptone. Just for example, I tested many, maybe in between 10 and 20, I tested 5, 10, 15, 20, 30, like that. Here also I tested 0.5, 0.25, 1, 1.5 like this. Here also I tested 100, 200, 300, 400, 500. So I'm definitely doing some test, but this study is having many problems. First problem is that, okay, we have done something, but have we ever tested that this 300 milligram and 10 gram per liter of glucose, maybe 0.5 gram per liter of this nitrogen will not be better? Have you tested anyway? Can you certify that? Maybe 300 milligram per liter when I'm putting peptone, then carbon 10 may be better, because you have never tested, you cannot certify. You have only tested the carbon change, only I have tested when my peptone was 100. I have never seen 300 milligram per liter of peptone and carbon of this 10 milligram per or 10 gram per liter. That means you are doing this study, but this study has a many loophole. And thankfully, you have not done a very great job also, because 15 flasks you have to study, and after that also you are not very sure, because I can ask you these same questions. What if I am taking 10 gram per liter of glucose, 1 gram per liter of nitrogen, and 300 milligram per liter of peptone? Have you tested anywhere in all this study? No. That means this study, even if you normally look logical, this is very wrong. And I will tell you very important things. This media optimization many people will do. For example, you are studying in a master's degree, you are doing research, PhD, maybe you are a faculty researcher also. And many people do it like this way. whatever I shown here, now OVAT approach, many people throughout the world still do this wrong procedure. They're having so many criticism. I can criticize any one of these study. These are not really good. Then question comes, how can I do that, sir? That is one approach. That is only things coming into your mind. If you ask me again so many questions, why you have not studied so many combination, then there is no limit. Try to understand, there is no limit. Then how is possible? So let me tell you one simple things now here, not simple, of course, complex rather. So for example, carbon and nitrogen and peptone. I had some values and I am telling, okay, you test 5 values, all 5. So for example, 10, 5, 20, 30, 40, everything in gram per liter. And nitrogen also I told you check between, okay, nitrogen was something 1 gram per liter, right? So for example, nitrogen also 5 reading, 0. 0.2, 0.5, 1, 1.5, and for example 2.0. And this one also 50 milligram per liter, 100, 200, 300, and 400. Many possibilities. If these are the possibility, and if I want to study all combination, can anybody tells me how many combination is possible here? I want to find every combination. Maybe with 10 I want to test 0.5, and with 0.5 I want to test 100. One flask will come, right? I want to test 10 with 0.2 and 0.2 with 300. I want to study. Another flask will come. If I ask you the same question here, I am having so many combinations, so many studies. If I am doing, how many study will be required? Any one of you can speak?
125.
Yes, very good, very good. Because here it is 5 combinations. For each of the 5 combination, I will have 5 combination of this. And for each of these 5 combination, I will have 5 combination of this. So what is happening? 5 power 3. Am I clear? So I think, is it clear, right? So this 3 is number of variable. How many things I am changing? This is called variable. And what label? This is called label. Okay, 10, 5 different label range I am testing. So 5 is label. If I do, let me tell you very simply and clearly, if I do all 125, if I do all 125 combinations, if it is possible, then maybe I may find out somewhere we are finding an optimal values, maybe more easy, but it will require so many number. That is the problem, 125. So I am telling to just criticize the earlier one, what I have done, 5 of this, 5 of this, and 5 of this. So OVAT, how much was there? OVAT approach, we had only 15 flags. But when I am going to same approach, 5, 5, 5 combination, if I am doing all combination, and you can understand that I can have 5 to the power 3, 125 experiments. So this kind of design for all combination of one, all combination of other. For example, this is 5 level. I can do in 2 level, 3 level also, no issue. If I am doing like this, all combination with all combination, that is called full factorial design. Am I clear? Because it is checking for all combination. If I do, that is called full factorial design. What is happening here? 125 flask. So you have to understand, if I do all combination, I am having this. I can say you that if I'm doing 125, we will know much information. Not only that, try to understand, not only that the best combination is what we have only tested. Not only that, we can actually find out a bigger picture. All combination, if I'm testing, will have a bigger picture. But the problem is there. This is 125 combination is really little high. We can have some other short strategy will come up. So basically, this kind of design, when I am going to check different level, different combinations, if I do, that will give me very good idea. But OVAT is very simple. I mean to say very simple, but it has not much power to understand, and that is called low resolution. How much extent you can do. Now, basically, when I'm talking about this kind of design, but then you will say, sir, what is design here? You are checking all combination with all combination with all combination. Anyone can say like this? Yes, of course. But there is another point I will tell you. Not only we are testing with different levels, we can test also more detail. And second thing, why I am testing all the level? Why should I test all 5 level? Why I am not testing only very low and only very high? I can do not only all combination, I can do only low, only high. Similarly, here also I can test only low, only high. Here also low and high. So it is possibility is there that I need not, just a second please. Aprada, क्लास चल रहा है ना तुम्हारा भी? ओके, मेरा क्लास चल रहा है. Okay, fine. So if you see, if I am taking just 2 level instead of 5 level, I can actually reduce my experiment number. Yes or no? First of all, you see, 2 level if I am doing, then what will happen? 2 to the power 3. That is more easy. 2 to the power 3 just 8. Yes or no? So you see, now I am coming into a point, I will not do all 5 level. I will do only 2 level for time being. And I need only 8 experiments. And this 8 experiment is even more powerful than your this 15 experiment. So basically, now I am coming to the point that when I am going to have many study, first thing is the level of the experiment. Okay, what level I am going to study, and I will tell you, not today everything, I will tell you this will have more powerful. How is it powerful? Question will come. Before I am going into more experimental design details, I need to tell you few terminology. The one terminology you possibly understood is the label. Label is means what range you are testing. Okay, for nitrogen this is label, for phosphorus this is the label. But now you see their values are all different. So instead of this thing, we normally approach 2 things. For example, I will write like this. That is called coding. Coding is used. Coding means instead of giving the number, I will give some +1, -1, like that approach. Let me speak one case. For example, I am testing carbon between 5 and 40. So what I will say, I will write here carbon, nitrogen and peptone. So for example, I am doing it in 2 level. 2 level means I will not take many, I will take only 5 and 40. Okay. But now if I make a code, what is code? I will say if it is low, I will give a number as -1. Instead of 5, I know it is 5, I will give a number of -1. So this is called factor coding, right? This -1 is the lowest one. Low concentration I am testing. 40 I will give a name as +1. Okay. So instead of this, I will say minus plus. For example, similarly, nitrogen, why coding is important, I will talk. Nitrogen is 0.5 and 2. For nitrogen, low is -1, high is +1. For phosphorus, for example, 50 and 400. So 50 is -1, 400 is +1. Now basically this is called coding. Everything I want to put in a range. Now for example, if I say like this, what about 22.5 gram per liter if I am testing? It is the midpoint, right? It is mid between this and this. And its code will be 0. So basically anything. So if I am using one code that 5 is -1, 40 is +1, then 0 is in between them. And if I say 1.5, you can also calculate. It is just two scale. This is one scale and this is another scale. So basically it is a new scaling approach we use, each of them independently, -1, +1. I can put 5 gram per liter is -1, 40 gram per liter +1. 0 is called center point or midpoint. So I can have this +1, -1. Here also -1, +1. So what is 0? 0 is 1.25. You see, average of this. What is 0 here? Here 0 may be 225. So this is called center point. Center point values for this, center point values for this, center point values for this. So basically coding is simple. You need to decide which one I will say -1, which one I will say +1, and which is center point. I will automatically find out. And if I am doing some study like this, why should I do only 2-level study if I only do 540? Now, okay, coming to a very big question here. I want to study all combination and I am studying only 2-level. 2-level means only I am studying 5 gram versus 40. Only 2-level. Now, question may come, sir, why you are not studying all other level? It is always good if I study more than 2-level. It is always good. I can take 5, 40, I can take even midpoint. So I'll always take one midpoint value, that is 22.5. So basically, this approach is always useful. 2 point is sufficient. Why 2 point sufficient? I'm normally assuming that in between 5 and 40, always microorganism is growing or reducing. Let me come to one point simply. For example, you are doing a study, everything is constant. I'm changing glucose between 5 and 40. I'm doing a study. So for example, this is glucose study. I'm doing at 5. I'm doing at 40. What does it look like? For example, I'm doing at 5 gram per liter. I'm just giving one example. And this is 40 gram per liter. All other things like nitrogen and protein remain constant. Constant means fixed. I'm not changing them. So for example, I keep it what level? 1 and 100, for example. So nitrogen everywhere I'm keeping 1, phosphorus keeping at 100. Now, for example, this is biomass. I'm just done only 2 study, 5 and 40. What does it mean? It is increasing, na? You may say that it is increasing. Yes or no?
Yes, sir.
Okay. But now I'm telling, okay, you have done only 2. Why don't you do at 22.5 gram per liter? Some mid value. So you are expecting that, okay, if I join it in 22.5 gram per liter, I'll have somewhere here. But unfortunately, you are getting a value of growth like this. When I'm testing 22.5 gram per liter, maybe my growth is here. Then what you will say? That means you cannot really tell that increasing glucose will always increase. It may happen because microorganism does not depend on you, right? It may happen that initially if I increase glucose, microorganism is having some repression. It is not growing very good. But after that, it can increase. So actually your profile is like this. But if you have not done the whole 3 point, you might have assumed, okay, sir, it is growing like this. So you have not seen the whole picture. You only assume that it is going like a flight, but you are actually going like a train, coming here, then going there. So actually, if I do more point, it is always good. For example, now also I am assuming this is high, but it may happen this was like this. So then it is always good to have more points. I can actually say the actual picture. But getting more point have also a problem. So always experimental design is a cost cutting process. I know if I do many point, it will be always good. I know if I take less point, I'll always save my money and time. So there is always a competition between accuracy and time or money. And like this, if I project 125 experiments, then people will not hire you, right? They will say, I don't need you. We can have some more cheaper approach. We need something more easy. Because after that also you will not be very confident. You cannot find out optimal very easily. I can have some other strategy. So actually experimentation is this experimental design, media optimization is a very vast thing. So I'm trying to give you what is the purpose. Should I go for 5 level? Should I go for 3 level? So basically 5 level is always good because I can see all combination and it may reflect this picture. If I am not doing, I'm actually sacrificing. So basically there are many approaches are there, many purposes are there. Let me come to the purpose. The first, when you are going, if you are getting a project of optimizing a media as a scientist, for example, you are working here, you need to have some strategy. You cannot test everything. You cannot delete everything also. So first thing is that I need to do some study where I will try to find out which factors are important. Why? It is very important. Let me say, coming to my point. We are testing 3 media composition, glucose, also ammonium chloride and peptone. And I told if I test all 5 versus 5 versus 5, I will have 125 experiment. So first question is that, is not there any some easy method which will tell that peptone is no important? No important means if I keep 100 or 400, it is not happening much picture change. So if I am having something to screen out, because this is only 3 variable, right? If I have some 10 media composition, glucose, ammonium, peptone, yeast extract, beef extract, NaCl, 6-7 components are there. And if you want to study each one at 5 level, then you understand if I'm having 6 or 7 components and each one I am doing at 5 level. So I think God cannot actually complete this work. In your 4 year, you cannot finish your job. Am I clear? So if I am having so many things, and if you want to do all combination, then you will become an idiot here. You cannot finish 7 into 7 into 7 into 7 into 7. I think I cannot calculate. I need a calculator for that. A very big number. You cannot study. And of course, your media may have 7 components. So basically, now I'm coming into slowly, you should understand the strategy. What should I? OVAT is impossible, right? If I do 1 variable at a time, I cannot find anything. It is very poor approach. Like this, if you do, 5 then 5 then 5 then. So OVAT will not happen. If I'm having 6, then 5 into 6, 30. 30 cannot do anything. So OVAT is actually failure. But so I need to do some strategy. So basically, it is not a, I'll come to the design later on. Today only introducing, so I need not put you much pressure here. So if I am having some 7 variable, carbon, nitrogen, glucose, phosphates, so many things. At the very beginning, if you try to optimize, then you are becoming a fool. Don't try to optimize. If there is so many factor, this is called factor, right? If there is so many factor, do not try to optimize them because the number of experiments will be very high. So what is required? I need something very smart design which is called screening design. Screening design, I'll talk about them. Actually in your syllabus we are having actually screening design. Screening design is not for optimization. It cannot tell you, okay, this combination you take, I will have the best biomass. No, it cannot do that. If I am having, for example, some 17 different parameter, na? 17 parameters are there, for example, and I will run a screening experiment. I need not do so many combinations. I can do with just 20 experiments. I can tell you which are important, which are not. So basically, screening experiment is done to classify. I'll tell you how it is done later on. You cannot learn everything today. So there is a screening experiment with very short number of run. I will tell you the name also. That design is called Plackett-Berman. So one Indian is already there, right? Plackett-Berman design. Okay, it came around 1950. So around 40, 50, 60 year approximately. I am not sure about the exact date, but I believe so. So Plackett-Berman design, I'll tell you how the design will look like, what combination I will take. It can be very useful to screening. So even if I am having some 17 variable, na, I will very quickly, I will do one small sets of experiment. What experiment I will do, we'll talk later. And I can tell you, okay, out of this A, B, C, D, M, N, all the variables was there, na? I'll find out, okay, A is important, C is important, and F is important. All others are, if I increase or decrease, does not have much impact. So if I classify it like this, that these 3 are important, and remaining all 14 are not important. Not important does not mean they are useless. Don't think like that. I'm not telling like that. I'm telling whatever you are finding a mid value, na, some reference value, midpoint value, you keep them. You keep them at mid, but you do not delete them from the media. Please try to understand. Don't misunderstood this concept. When I am doing, I will be talking about screening design. That design is only to tell you which factors are important, which factors are not so important, so you can keep them somewhere. Don't try to optimize them. So what will happen? Your job is little bit reduced. So if I'm doing the screening part, my job is little bit reduced. Now I'm only having 3. Remaining 14 is there, but I will not speak about them. They're there in base level, fixed level, they are all maintaining. Now my question will become out of only the 3. Now if I'm having 3, then, so do you think that I will do all the, maybe 3 is the, this thing, factor, and for example, there is 5 level, then do you think I will do 5 to the power 3? No, I will not do that also. We will have further which is more important, which is less important, we have already done. Then I will try to find out which is maximum effect. What is the effect of A? What is the effect of C? What is the effect of F? I will try to find out. And then I will show you this design. This is actually, first one is screening. Second one is finding the effect of A, effect of C, effect of F, I can find out. And then I will find out the optimization rule. Of course, I will not take 125. There is some other strategies also there. This is called optimization design. And one of the example is, I'll just take another slide. So basically, there is this label, how you should proceed. First design is for screening. Then find out important factor. Okay, important factor. And not only important factor, you can actually make a model so that you can predict also. Okay, if I take this, how much will come? Can you tell me? We say yes. I will find out what are really important and what is their relative importance, which is more, which is less. Not only that, I'll talk about that. And this is coming under, so screening design is one of them, is Plackett-Berman design. This is known as full factorial, or I'll talk about next class, fractional factorial design. After that, for optimizing, finally you will tell this is the best combination. Optimization will come. And this coming under response surface methodology or RSM design. One example of RSM is central composite. I'll talk about them later on. Design, or simply CCD. So basically, the task is not so easy. First one, you screen. Why I am screening? To reduce the number of variables so that it is more easy to handle, right? If it is so many, I cannot handle. Then I will do full factorial or fractional factorial. Purpose, to know the effect, main effect. If there is any interaction effect, I'll talk about interaction next class, not today. We'll try to find out the effect. And last, once everything is done, this experiment will be little bit bigger, okay, little bit higher size. So this is very low number of experiment. Low number of experiment. Here moderate number of experiment will be required moderately. Here little bit high. Of course not 125. Okay, I will talk about the design later on. So slowly, initially screening, you don't do so much. You don't invest your time on screening. When I'm going to know the main effect, don't use much there. When I'm going for optimization, you use moderate size. You use 5 level. Most of the time, response surface design is done at 5 level, because now I'm looking for optimal value. As I told you now, the glucose example here. Here we should like to take 5 level. That will be more easy. But when I am doing this design, when I am using this kind of factorial design or fractional factorial design, we will not take 5 level. We'll normally take 2 level. Response surface, we will take mostly 5 level. Because here I need to be more confident, right? So I am looking very combinations, but all not combinations. And here also mostly you will use 2 level. So basically, but 2 level is not strict. You may use 3 level also. So there is many possibility. We'll talk about those possibilities. We'll talk about those aspects in our next class. So I hope you understood the steps we should take, basic steps: screening, understanding which are important, which are not important, what level of important, what is the main effect. You'll understand. And this information can also be used to find out some optimal value moderately, not very rigorous. Then I am coming to response surface, truly optimization. And that time I will tell you, or you can find out what is the optimal combination of the variable giving your desired product. This experimental design is not only for biotech, it is always used in all industry. Anyone trying to optimize will have to do this design. Anyone in any field, not only for biotechnology or media or microbiology, in any domain, they are still very much useful for their implied applications. I think I will stop it here right now. Many things are there. I will talk again in the next class. Just for intro, I think that is sufficient for the day. If you have any questions and queries, you may please tell me. Any questions or queries from you?
No, sir.
Okay, thank you. So if you have no questions, queries, I think I'll stop this recording and you can leave this class.